One other method to determine the enthalpy of a reaction is the standard enthalpies. These are called standard because they are measured at standard states that are generally chosen for thermodynamic functions, 1 atmosphere pressure and 25 degrees Celsius temperature. If a property is given at standard states, it is indicated with a degree sign next to the symbol of the property. Since we cannot measure the absolute value of enthalpy, by convention, elements at standard states are assumed to have zero enthalpy to set a reference point. For example, the standard enthalpy of oxygen as O2 gas or iron as iron metal are zero. Using this reference point, we can determine the relative enthalpy of compounds, which is called their standard enthalpy of formation. The standard enthalpy of formation of a compound is the enthalpy change for the reaction where 1 mole of the compound in its standard state is formed from its pure elements in their standard states. Because the elements are assumed to have zero enthalpy, the enthalpy change of the reaction gives the enthalpy of formation of the product, the compound. In this notation, delta shows the change in enthalpy. The degree sign signifies that it's the standard enthalpy change, and F indicates that the substance is formed from its elements. The enthalpy of formation values are listed in tables, which is standard in all chemistry textbooks. You do not need to memorize any of these values, as they will be provided to you within questions. However, you need to remember that elements in their reference forms have zero enthalpy of formation. For example, chlorine has a zero enthalpy of formation as a diatomic gas. As a monoatomic gas or a monoatomic gaseous or aqueous ion, it has a non-zero enthalpy of formation. It has a zero enthalpy of formation only when it's in its reference form as the diatomic gas. If a reaction occurs at standard state, then the enthalpy of the reaction is called the standard enthalpy of reaction and can be calculated from the standard enthalpy of formation of the reactants and products. Recall that the change in any state function is final minus initial. Therefore, the enthalpy change of a reaction is equal to the enthalpy of products minus the enthalpy of reactants. This is what is given in the summation law, which states that the standard enthalpy of a reaction is equal to the total enthalpy of formation of the products minus the total enthalpy of formation of the reactants. In this equation, the Greek letter sigma means sum of, and n represents the coefficients in the balanced chemical equation. If the standard enthalpy of formation values are known, then the standard enthalpy of any reaction can be calculated. Let's calculate the enthalpy of this reaction using the standard enthalpy values of the reactants and products. The first thing to do is to write the standard enthalpy of formation of each reactant and product for easy note-keeping. Then we are going to use these enthalpy values in the summation law. Recall that the summation law has the sum of the standard enthalpy of formation of the products minus the sum of the standard enthalpy of formation of reactants. Our products are nitrogen monoxide and water. For nitrogen monoxide, we enter 4 times 90.3, 4 times its standard enthalpy of formation, plus 6 times the standard enthalpy of formation of water. This makes the first section of our equation. From that total, we're going to subtract the sum of the reactants. 4 times the standard enthalpy of formation of ammonia plus that of oxygen. Since oxygen is 0, you can omit this as well. Once calculated, the standard enthalpy of the reaction comes out to be negative 906 kilojoules.